Hey, good morning, Algebra 3 students. We're going to today take a look at your material for graphing the sine and cosine and tangent and cotangent functions. Again, just to review for your quiz. The quiz will be given in two parts. There's only 8 questions, but just so you can get your head around it, tomorrow you'll do 4 of them, and then on Thursday you'll do 4 of them, and then you'll be heading into a nice Easter break. So that will be good, and we'll come back fresh, ready to learn about secant and cosecant graphs. But just to remind you, they're based on the basic graphs. So when you're doing this, you should probably have these basic graphs etched into your mind. So let's just go over these basic ones again. All right. Your parent function for your sine graph is going to have a period of 2 pi. Remember, for that, your basic graph has your 0 points at 0 and pi and 2 pi. And remember, whenever I'm looking at these graphs, I'm going to be looking for some key points. I'll be looking in the sine graph for where the zeros belong, and then your general pattern is go up to 1 and down to -1, so that it cycles around, and then you'll do your very best to sketch in your nice curve that goes around. And I'm doing this somewhat live, so you can see that I'm looking for a nice curve. I'm looking for definitely not a point, but also I'm looking for you to go all the way up to the top, make these points distinctive so that I can tell exactly that you know what you're doing, where they belong as far as where they begin and where they end. Okay, for a cosine graph, I'm going to be you need to make sure that you are, once again, you're going fully to the top and fully to the bottom where they belong. For a cosine graph, once again, the period for a standard graph is from 0 to 2 pi. So we start by putting in your 0 spots. There's only 2 of them on this for a one complete period. But remember, they do go on and on. For this particular quiz, I'm only requiring 1 period. So your basic one for a cosine will start at the top, go to the middle, go to the bottom, go to the middle, and back up to the top. And then once again, you're going to sketch in as best you can the way that the curve comes through and goes down and comes back up and goes back up. Now this is your standard normal cosine curve. Okay? So you know that what happens is that it gets adjusted and it gets changed a little bit. It gets sent to the left, sent to the right, sent up, sent down, based on the other numbers that are around it. But you've got to have your baseline ones to start with. You have to have firmly fixed in your mind. That's what a sine curve looks like. This is what a cosine curve looks like. Same with tangent and cotangent. We need to have your idea of that going on. Okay, remember, for a tangent curve, you have your period is just 1 pi long, starting at -pi/2 and ending at +pi/2. This is a 1 and this is a -1, which are also important. You need to recall that there are asymptotes here, so I'll expect you to put the asymptotes in where they belong. Once again, this can be done on a standard sheet of notebook paper. This is why, since I don't know if you all have graph paper, and I can't really send you the special graph paper as easily for this, I'm just saying do your best on this. This is obviously not the most perfect dashed line, but I can distinctly see where it belongs. I can see that it's going through the correct spots. Remember, on these you have a 0 here, and your tangent function is starting down and it's moving in the upward direction. Okay, so that when you actually draw it, it's easier to start at your middle point, go up through, and make it so that you're approaching that line, not actually going over it, but I am going to look for this key point. I'll be looking for this key point. I'll be looking for not a completely straight line, so you have to curve it as best you can down through, and then down like that. Now it would be an actual straighter one. It is very hard to draw on this. It's a little easier on paper or on the board. But just so that you see that I'll be looking for something that approximates that. Now, of course, these are going to move up, down, left, right also. So this is just your review. And then the cotangent function. Okay, our basic one. Now we do have asymptotes in here. I'm just going to change the color so you can see right here. There's that one. Once again, the period is 1 pi in width. It goes like that. Your 0 point, I'll be looking for that. I would be looking for one at 1. I'd be looking for one at -1, or if it's stretched, it might be at a different number, but that's the general idea. And once again, you can curve up starting at your point there is the easiest way to get it to go, and then curve down through this point down here. Ooh, wow. There we go. Okay, so you have your tangent, you have your basic cotangent, you have your basic sine, and you have your basic cosine. Now, what we want to do is I just want to review with you how to move these things along, because we did them as individuals, but on your quiz they'll be mixed. You'll have 4 to do one day, 4 to do the next day, so it's not too terribly a lot, but I do want you to do a good job. I am looking for all those things, and I have it laid out as far as how many points. I'm going to be looking for asymptotes for a tangent and a cotangent. I'm going to be looking for that middle point. I'm going to be looking for these points to be placed correctly, and for your best curve, even if it's not perfect, so that it's not crossing over the line, but it's kind of curving up so that you can tell that it's going to get close to it. For the sine and the cosine, I'll be looking for the right shape of the graph. I'll be looking for the 3 anchor points for the sine and the 2 anchor points for the cosine, and whether it goes up or down first the way that it's supposed to do. All right, so let's take a look. I have an example of each one that I plan to do with you from beginning to end. All right, so the first one is a sine example. So what I want to do is, for the sake of being able to show you so that you can see it, I just want to bring my sine graph with us. And this is what you're mentally going to be able to do. This is the best I can do as far as mentally doing something. We'll see if that actually did what I wanted it to do. Aha, there we go. All right, so we've got this basic sine graph here. I'm just going to make that a little smaller so that we can deal with it. Let's make it half size. I just simply want it to be a little bit smaller, and I want it to be proportional. So not 500, there we go. I'll do it that way rather than just dragging it smaller. So we have this is going to be our little ready reference that we're thinking, okay, this is what I'm basically dealing with here. You need to keep in mind what's happening and identify what each one of these things is going to do. So like, for example, this one is going to bring the whole graph down 1. And then you need to also figure out what your range of values is going to be for one period. So as you know, we take that number and you put it between For a sine or a cosine, you're going between 0 and 2 pi, just to remind you. And this is all beginning work before you can even start to graph, but I will be looking for everything to come out right, so you've got to be careful here. So I'm going to divide by 2. Now, whatever it is that comes after that you're taking the sine of, that's what you need to make sure that you're putting between 0 and 2 pi. So here we have 0 less than x less than, that's technically less than or equal to, but it's okay. And then this is pi. Really all we're doing that with is so that we can find the beginning and the end part. Okay, so our beginning is at 0. Our ending is at pi. These are the places where you have a 0 mark in there. Our other place where you get a 0 is the very exact middle between these two. If you recall, you find this middle point by adding and then multiplying by a half. Okay, so this one becomes pi over 2. In order to find this middle piece, you need to add these two and divide by 2. Or easier to multiply by a half. So this is pi over 4. And then this one, you need to add. Okay, which would give you 3 pi over 4. Okay, notice a lot of this can be done without a calculator, so that's really the route that I'm taking with this. So we have our 5 points for all of these graphs. You're really identifying 5 different important numbers. So then you would take your piece of notebook paper, you're going to draw it out, you're going to make your whole period going from 0 to pi. So you would do something like that. Your notebook paper would already have lines on them. Put that back the way it belongs. Okay, so you wouldn't have to draw on these lines because they're already going to be there for you. And this is something that I will need you to take a picture and send me. I can't evaluate your graphs by just having you put it in a Google form. It just doesn't work. I haven't figured that out yet. So so what you're doing, rather than having a 0 to 2 pi period, you would have your pi put in here. You would have your pi over 2, and the easiest thing to do is put your first one in, then put the second one right in the middle, and then the middle of the middles for the other ones we put in pi over 4 and 3 pi over 4. You're then going to, because it's a sine curve, oh wait a minute, we need to also keep into account that it's going down 1, so we haven't taken into account that yet. So in order to go down 1, you've got to take this middle line, and instead of going up 1 from the 0, we need to put in our little dashed line. I'll be looking for that too. So you've got your beginning and your middle and your end and all those things put in, but then we need to shift the whole thing down. So you're going to need to go to the other line here. Put one of these in. You're not going to put it in. You're going to have a piece of notebook paper, so this would be another line down here that's going to be important. All right, hopefully you see why, because our middle part, where it starts on a sine graph, has to be moved down. Okay, so you've got that part started right there. So beginning, and the middle 0 goes here at pi over 2. and our last one goes here. Okay, so we've got -1, 0, -2. It's cycling between 0 and 1 in this case. We've got our zeros plotted right down here along this for a regular sine, and I didn't do any funny business with turning it upside down for you, so just so you are not really necessarily having to look for that. So then from here we go up 1 unit, and it goes to here, and then it's down 1 unit, so that it has this curve shape that matches the sine curve. So you've got the middle, you've got the up, the middle, the down, and the up, and you draw in your nice curve going up through, coming down through, making sure that you're going completely to the top and completely to the bottom. I've got these nice large dots there to show that I really meant to do that. So the whole thing got shifted down 1 because of this number. This part goes in the middle. That tells you where your beginning and your end and your middle is. And then you make sure that it fits that sine pattern. All right, let's review for the cosine. Now, keep in mind, though, there's variations on this. You could have another thing in here, like a plus or minus, so it could go like that. You could have a stretch over here. So if I had like a 5 here, I don't think I did quite that extreme, but instead of going up 1 for this, you'd have to go up 5 and make it a really tall graph that went up and down that many. So, you know, if you do need to go back and look at some of the other videos to get more specifics, that's fine, but this is kind of a good consolidated thing. My next example is a cosine graph, so I want to grab a cosine graph so that we have that there for reference. Let's grab that. And we'll bring that forward to our cosine example. Oops, it didn't want to behave. Let me go and make it behave a little bit better. I'm going to do, I know you can't see what's happening there, but actually there's just a little trick. It's a little bit, there we go. So I've got my cosine that I'm just putting here for my ready reference. I want to change its size a little bit so that we can work with it a little better. Make it half size. There we go. So we can see, okay, there's our cosine that we're just kind of holding in reserve here so we can see it really well. So, all right, so we need to consider here. Now, this 3 out here this time is not moving the whole thing up or down. What this 3 is doing is it's stretching it out 3. Okay, so that means that we're not going to be going from 1 to -1. We're going to be going up to 3 and down to -3. So you've got that in the back of your mind. This part right here is what tells you what's going between 0 and 2 pi. 0, x minus pi over 2, and 2 pi. So we need to get x alone in the middle, so we need to add pi over 2. Plus pi over 2. Okay, the nice thing is that this one on the left is always going to be super easy. Okay, just to remind you, 2 plus a half is 2 1/2, which is 5 pi over 2. Do always make them into improper fractions, so 2 plus a half, 2 times 2 is 2, 4 plus 1 is 5. All right, so we have this. Now, you've got your beginning and you've got your end, so we have to work on finding those middles. So let's do that. I've got pi over 2 at the beginning, and I've got 5 pi over 2 at the end. So I want to add those. pi over 2 plus 5 pi over 2 times a half. So this would be 6 pi over 2, right? 6 pi over 2 times a half would be 6 pi over 4, which gives you 3/2 pi, or 3 pi over 2. So 3 pi over 2 in the middle. Then we need to do the same thing for this. Pi over 2 plus 3 pi over 2 times a half. Everything does need to be simplified, by the way, so I'm taking my time to do this with you. So this would be 4 pi over 2, and 4 pi over 2 is the same as 2 pi. 4 pi over 2, 4 divided by 2 is 2, and a half of 2 is 1, so this one will be just pi. Over here, once again, 3 pi over 2 plus 5 pi over 2 times a half. So 8 pi over 2. 8 pi over 2, 8 over 2 is 4 times a half gives you 2 pi. All right, so you've got your numbers here. You've got pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. So these numbers are important. We can begin to make our graph then. You also have to keep in mind that you're going to be going up 3 lines and down 3 lines when you do this. So you're going to give yourself a little space, keeping in mind that we've shifted this whole thing to the right. And so, but you do have to always start your graph with a 0. I'm keeping in mind that I'm going up 3 lines and down 3 lines. So I'm just making this a little bit. Okay, so we're going up 3, whatever notebook paper you have. This, I think, actually is a little bit easier on notebook paper than graph paper, if I'm not mistaken. And in your notebook paper, you're going down 3 as well. This is going to be a very stretched out graph. Okay, and then you're going to put in your different things. We do have a 0, so be careful you're not starting this graph on 0. Okay, we're going to go by pi over 2's on this. So we'll start here. Here's a pi over 2. And here's a pi. And notice I'm making nice as even increments as I can. 3 pi over 2. And 2 pi. And 5 pi over 2. So here's the thing with this. If you want to spread it out more this way, that's perfectly fine. Because what we're really doing is we're establishing on our x and y axis where these numbers belong. This is 1, 2, 3 this way. This is -1, -2, -3. I'm looking for key points. I'm looking to make sure that we're not starting at 0, we're starting at pi over 2. And where we're starting at pi over 2 is up here at 3. You're making it match this graph. So you start at the top. This number tells you where the top is. It's 3 away from that midline. And then you go to the middle, because here we go to the middle next. And then you go to the bottom, because here we go to the bottom next, and then up to the middle, and then up to the top. Now this one, I wish I could do this on paper because it's very difficult this way, but we're curving and coming down through here. And then we're continuing to come down and making a nice curve at the bottom, not a point, but a curve through here as best as you can. And then you're coming up through here. Okay, and you might notice, while your curve is not perfect, Mrs. Dowdy. No, it is not. However, what you can tell by looking at this, and I've run into this with students with handwritings over the years, is you can tell that on purpose I'm not making a straight point, because you can tell that there is definitely a distinctive curve, so that counts for you and for me. You can tell right here that I didn't go straight up here to make it a straight line, but I curved it up. You can tell also that I'm not intending for it to continue up through this point, but it is intended to curve at the top and at the bottom. So I'll be looking for those type of things. I'll be looking for 1, 2, 3, 4, 5 distinctive graphed points for a cosine, also for a sine. And I'll be looking to make sure that your shift, if there's a shift, that it moved the right way, that you've got your key x-axis places marked. I'll be looking to make sure that if there's a stretch, that it stretches appropriately. If there's no stretch, that it doesn't stretch. And just like what we just did with the sine graph, I'll be looking for if the thing was supposed to shift down, or if it was supposed to shift up, that I'll be able to see that distinctly. So that's sine and that's cosine. Tangent, we're looking for slightly different things. They're all basically the same process, just different graphs to start with. So we're going to look for a tangent graph, so I need to go and grab my tangent graph so that I have something to refer to. I've got that. I'm going to bring it right along for us so we've got it to refer to. Okay, we'll drag this out of the way and resize it. Oh, I did not mean to do that. Definitely not. There we go. That's why I love undo. I do want to resize this though. Okay, so we have this for our little reference over here. So you're keeping in mind that a tangent goes from down to up, and that you are looking for asymptotes. And those asymptotes for a standard one go from -pi/2 to pi/2. Okay, got that. All right, so we're going to start with this, and we put, there's no up, down, left, right, there's no stretch, so that's nice. So we put, instead of going between 0 and 2 pi, we put it between -pi/2 and pi/4. If you put the less than or equal to or just the less than, it really doesn't matter, because really your important thing is to be finding these beginning and end parts. Okay, so we need to then add our pi/4 so that we can make this x by itself in the middle. And when we do that, we get x by itself in the middle. A half plus a fourth is 3/4. And -1/2 plus a fourth is -pi/4. All right. Then you need to find, and this is where your asymptotes are going to be. Then we need to find, once again, we need to find the middle, and we need to find the middle of the middles, so we can get where those other key points are. So we've got pi/4, 3pi/4. I want to add them together and multiply by a half. times a half. So this is 2 pi over 4 times a half. So that gives me pi over 4. There's my middle. Okay, this is where one asymptote is going to live. This is where the other asymptote is going to live. This is where 0 is going to live. We need to get this. So negative pi over 4, oh, I like when this happens, plus pi over 4 times a half. But hopefully you recognize this is just 0, so that's helpful. Okay, in this case, because I'm talking about my tangent function, that's where negative 1 is going to live at 0. And then pi over 4 plus 3 pi over 4 to get that point. And a lot of you that are really good at fractions really might not need this as much, but just for those that still struggle, this is 1 pi times a half, which is pi over 2. And that's where 1 is going to live, because in our general form for our tangent, we have 1 living right here. So I've got all that work that I just did, but I want to pull this up where we can see it a little better for our graphing purposes. I'm just bringing this up here. I don't want to cover anything else important like I'm covering right now. Okay, so we've got these important things. This is really giving us our skeleton for our graph. So what you're going to do is you're going to then make it into a real life graph. We have our x and y axis here. I want a little more open space actually. Let's get some more open space. And so here we have our x-axis and our y-axis. I should probably have given it just a little bit more room because I have to get over here to our negative. So there's enough room here. I'm going to go to negative pi over 4. Then I go to 0. And I go to positive pi over 4. Notice that if it's a gap of pi over 4, I want to leave it as a nice same gap, at least, you know, notice I'm not measuring it, but I'm also trying to be careful to get it at least close. I know that you're dealing with different supplies right now, but you can still do this. I think everybody can do this part, and that's going to be good enough. So what I will be looking for, I'll be looking for your correct labels. I will be looking for your asymptotes to be drawn in for a tangent, also for a cotangent. So we've got that. You're going to sketch in your cotangent. I'll be looking for where 0 is. 0 would be your middle one. And then I will be looking to see that on your lines, you're going to have some lines in here because you've got notebook paper, so that's convenient. So you've got, at least I hope you do. If not, you're going to be doing it like I do. You've got some kind of paper somewhere, I'm sure. All right, so we have our 1 and we have our negative 1 here. So 0 is where negative 1 lives. The pi over 2 is where positive 1 lives, so that you have a basic graph for your for your tangent. It goes up like this and then comes down like this. I think this is better than what I did the original one. Down like this. Okay, so your tangent graph looking like that for this particular scenario. So once again, you're trying to find your beginning and your end and your middle, and then these points, I'm going to be looking specifically for this point, this point, this point, that you did your best to make the nice curve that's going from down to up for a tangent, and that you've got your asymptotes in, and I'll be looking for where those are too. All right, one more for today, and then that'll be enough for review, but it is good to have all this information consolidated into one place. The last one is a cotangent example, so I'm going to pull this cotangent graph here. These key graphs are super important to you. Knowing what the basic one looks like, the parent graph, so that you can build the other ones from it. Let me make it just small so we can deal with it. Okay. I'll get it kind of out of the way, but you've got your notes nice and big there for yourself. All right, so cotangent, let's think about what these things are doing to the graph. This one out here by itself, this is going to move the whole thing up 2. Cotangent 1/4 x, so that means for cotangent you're going between 0 and pi. So 0, 1/4 x in the middle, and pi on the end. So when you do this, you're going to multiply all sides by 4. It gives me 0 and pi and 4 pi for my beginning and end. So that's convenient. So I have 0 and 4 pi directly in the middle. If I add these and divide by 2, I get 2 pi. Add these and divide by 2, I get pi. Add these and divide by 2, I get 3 pi. It's probably the easiest one of those that we've done. The beginning and the end are asymptotes. The middle is 0. Okay, so far it's the exact same process as for tangent, except for cotangent just works a little bit differently on here and here. Now notice that this is up 2, which means that instead of being 0, we have to move the whole thing up 2, so it changes it to a 2. Okay, I am looking for that baseline that's kind of like a 0, but since the whole thing moved up 2, that changes it to a 2. This one here, it starts one above. It starts one above wherever your base was. So this one will be a 3. This one goes one below that, so it'll be a 1. Sometimes rather than drawing it out like this, straight to making the graph. So let's get into making this graph. I have to go from 0 to 4 pi. So my little tiny graph here is kind of in the way. I'm going to do that. There we go. And I'm also running out of room on the top, so we're just going to pretend it's college ruled paper here real quick. Okay, because I need to move the whole thing up 2. So let's do that. So we're going up 2. 1, 2. But I'm also having to consider that means that my anchor points are going to have to shift also. I'll just make kind of a whole notebook sheet here. Okay, so there's your notebook paper. And my increments are 0 and pi, and it's kind of good for you to see all this happening. because this is what you're going to have to do. You're going to have to do all these steps, and 2 pi and 3 pi and 4 pi. You need to put in your asymptotes. I'm using a different color, but then that would be helpful. If you have a highlighter, that's really good for showing me your asymptote in here, because it's hard to see the 0 one. But if not, just make it nice and as bold as you can. 4 pi also gets an asymptote. I do want you, because the whole thing got moved up too, I want you to draw a line this way also to show me that you know that the whole thing got moved in. This is not actually part of the graph, it's just part of the framework. So this point here, here's your 0 point that goes at 2 pi, which changed into a 2 because everything got moved up 2. For a cotangent graph, it starts 1 up from that point and then 1 down from the point because it's starting up and going down. And then for this one, it's a nice curve that comes down through, curves through here, loops down, curves through here, and then is curving back like that, so that it's approaching the asymptotes but not actually going to it. Okay, so once again, your cotangent is going from up to down, and your tangent is going from down to up. You have to figure out where your beginning, your end is. If there had been something like an x minus pi over 8 here or whatever, it would have shifted it left or right rather than stretching it out this way. So all of these involve whatever is here, you put between whatever your two markers are for sine, cosine, tangent, cotangent. Same process, it's just the beginning and end change. If there's a number here, it stretches it out. If there's a number here, it moves the whole thing up for positive, down for negative. And I'm confident that you can do this. I hope this review was helpful for you and that you're having a great day. And I'm praying for the end of this, and we'll get to see you soon.